Is this thing on?
Okay, we'd like to welcome you to our mini-seminar. This is our third mini-seminar. I see some familiar faces that have been to the other two. I see some new faces, and I see some familiar faces that have never been to one of our seminars. So I'd like to welcome you to the seminar. AIRON is acting as a proud sponsor to this event. The event is on energy management, demand response, and energy analytics. We've got two guest speakers with us today, Ted Baker with Rodan Energy Solutions and John Petsy of Sky Foundry. Both of them are going to speak on some very interesting topics that I think are going to apply to the direct businesses and obligations that most of the people in this room have to the places that they work. What we're going to be speaking about mostly today, the theme of this presentation is going to be mostly about building automation system services. BAS systems that we've been installing over the past 15, almost 20 years, we've always found are, for the most part, underutilized. We've got 300 active installs out there, 20% of which are under service contract. 70% of them we would give ongoing service on, and about 60% are used every day by the staff, facility managers, etc., that perform a log on and check function on the system. What we're going to demonstrate today is how you can put your BAS system to work proactively. Today's speakers are going to show you how to do that. They're going to speak to products that they have, services that they offer, and programs that are out there that are going to put money back in your pocket. What AIRON provides, our methodology or our system for proactive building automation system use is what we call AND Technologies. We're going to show you a live demonstration after the break of AND Technologies at work, and you can see through that demonstration how the system can reach out to you and tell you what's wrong, rather than you having to log on, go into the alarm pages, find the problem, and do a lot of self-diagnostics. Just before we get started, I'll give you a little bit of background on AIRON. AIRON was established in 1993. Today, AIRON is a full integrator services group. We have applied partnerships with the best product manufacturers in our industry. During the break, you can kind of review the products tables. We've got representatives from those product manufacturers here to certainly share ideas with you and discuss the products. We also have partnerships and relationships with the industry leaders that will shape the industry into the next phase of environmental responsibility, and that's what we're going to speak about mostly today. Today we have two feature speakers. That are part of that movement. Without further delay, I'm going to introduce Ted Baker of Rodan Energy Solutions. Ted is a seasoned energy conservation specialist with Rodan Energy Solutions. Energy conservation and demand management are his passion by helping companies and organizations learn new ways to reduce their facility management's energy footprint and to use government-assisted programs to improve on the project feasibilities. So without any more delay, Ted, come on up. Thanks.
Well, welcome everyone this morning. I wanted to say thanks to Rick for having me out. This all started, I guess, back last October. I was at another Honeywell presentation, and I heard a lot of interesting comments from the contractor base from Honeywell, and it was shared, and I'll never forget that day. Rick stood up in the room and shared his comments that it's very, very difficult. This is a hard business. He's been at it for 20 years, like he said, and to try and make a living at it, grow the business and survive, and it's tough. So, I respect you guys for coming out, trying to learn, develop new opportunities, new ideas. And I guess to that point, Rodan is a company that has identified this market as a strategic growth market. Demand response is a unique product in the energy industry. And I guess Monday night it was at the Electrical Distributors Association. They're celebrating 100 years of delivering electricity in the Ontario market. Sounds like a pretty good thing. And the guy, Sir Adam Beck, threw a switch in 1912, and we then had electricity from Niagara Falls. So that was a big change for the market. And demand response, I guess, is a key component. So I'll start basically with Rodan, and we're a smart energy grid company. We provide a lot of metering services for the big power producers in the province. We are, I guess, a leading meter service provider to the nuclear industry, to any power producer, all of the facilities that generate power. We are their settlement agent for their metering. So they get paid based on our meters that we look after. And based on that experience in working with the ISO, we have the ability to understand the demand in the province. We are a key, I guess, vision. We have a daily vision of the demand in the market, so we can have a suite of customers that can curtail. So we activate them when called upon. We also deliver the Peak Saver program. I don't know if anyone in the room here has one of the smart meters in their home that gets shed when the province is in distress. That signal comes from our Mississauga head office, and we have 220,000 homes under that program in Mississauga. We help a lot of the big power producers with the regulatory assistance and just figure out this marketplace and how we can contribute to that. So demand response, what is it? And I guess to start, it is a contractual obligation, and that's my job out in the street and out in customers, and to introduce it to you folks. It's a contractual obligation to reduce energy consumption by a set amount for a set period of time. And the ISO, or the province, rather than importing expensive power from the US or from Quebec or wherever else, or rather than turning on a peaking generator, they will activate our suite of customers, or our portfolio of customers, to reduce that set amount. We have almost 300 megawatts under contract, so we act as a power production facility by reducing the grid rather than producing onto the grid. So it's a unique way of creating a stable grid. So the activation notice is a very specific. It's all done in a contractual fashion. It's done from 12 noon, I guess, up into as late as 9 p.m. at night. So a commercial building, for sake of argument, would only be participating from 12 noon to 6 p.m. So they wouldn't be forced to do anything up until the evening. But a lot of the bigger industrials, they have processes that they can shift or shed to a later period. And for that, there's a fairly significant financial remuneration for doing that, for shifting operations or curtailing. Some of the big steel mills can simply turn down a blast furnace for 4 hours. That is a big sigh of relief to the grid. You know, on one of a screaming hot day in August, they can turn all of that stuff down. We activate a lot of the smart appliances that are out, and I'll show I've got a slide up in a few moments that'll share some of the other devices. And I talk to Honeywell regular, trying to figure out how I can get those magical little boxes into more locations. And I guess the goal is to get the contractor base to understand that creating a plan to curtail, creating a DR day protocol, as I like to call it, that's my acronym, or my way of putting it. When you do that with a building automation system, for that protocol, you can get paid. It's got to be a repeatable protocol. It's got to be a deliverable. You need to be able to discern on a hydrometer, a revenue grade hydrometer, because that's what we use for settlement, is the customer's revenue hydrometer. When they reduce that set amount that we've contractually enrolled them for, they will get paid. And it's a fairly substantial payment. Again, I've got a slide for that will show you how it works. It doesn't happen without having a system in place to do it. So that's why I've focused on the contractors, the delivery agents of building automation. I think that's why Rick and I have started this whole process, is to try and educate the group that creating a protocol, embedding it from the very beginning, will help fund some of the upgrades. Customers don't want to connect a whole bunch of loads. The idea is the more loads you connect, the more performance you can deliver, the greater the incentive or the revenue opportunity. So the idea, and he alluded to it in his initial speech, where I can help pay you. I have a difficult time paying you guys specifically because the contract I have to enter into is with the customer, and it's a provincial program, so the customer is the recipient of the funding for their work. But you guys benefit from installing more systems, more technology, wider, deeper, and I guess our other presenter will explain with his solution on the analytics that will go with that as well. So what does DR accomplish? And I guess before I state what it accomplishes, there's a reason that it is required, and it is truly a balance of supply and demand. Peak days, peak periods, and it can also be for generators that are down for maintenance. There's many situations where we get activated, or our customer base or portfolio gets activated, because there's various things under maintenance around the province, and there's an unexpected spike in the grid, or a weather event, or a generator goes down, or a power line goes down. They will activate. So the program has been in existence since 2008, and it's growing continually. And I'm sure you've all heard of the CDM program, Save on Energy, across the province. It's a similar program, but it's for a one-time incentive for work being done. Ours is an ongoing program that's used to curtail, would be the answer. So it basically gives a temporary reduction, it's on the contracted amount, and it helps stabilize the grid pricing matrix. I guess there's 3 trigger points that affect demand response in the province. So you've got a supply cushion. The system has got to have enough capacity. If something goes down, they've got a cushion built in. If that cushion gets eroded, we will get activated. If the price of energy in the province hits a certain trigger price, the HOEP, H-O-E-P price in the province hits a certain trigger point, we then get activated. And I guess the third way would be a combination of those two, a smaller cushion and a price performance issue. So it all kind of ties back to a smart grid, which is the analytics and what you guys can all contribute to, and having smart buildings and being able to talk to the buildings. We need to have a smart grid in the province. At the meeting on Monday, the minister, Mr. Bentley, was very proud to say that they've installed 2 million meters, I think, in the province of Ontario, and it's virtually complete. There's some jurisdictions that are still trying to get the communications worked out, but 2 million meters across the province has been done in 3 years, which for the electricity sector, guys, it's staggering. Hydro One operates on a 5-year approval process and a 10-year implementation process, so that when you understand the energy sector and how slow it takes, and it's, to get, number one, the rollout of the smart meters done was pretty impressive, and to work with that group in a 10-year business cycle. I don't know any business cycle that can work under a 10-year business model, but that's how they do it. So the next image is basically a picture of the smart grid. It kind of gives you an overview. We've all seen this before. We all live it every day. The idea is creating a truly smart grid and creating buildings that will talk to one another. I rely on you guys installing systems and strategies to help buildings communicate better, understanding how the system or how a building can perform better. And again, my counterpart here has got a software that will do that and integrate into that. And I guess AIRON is trying to be a leader in this field as well. Rodan has got contracts with many different LDCs across the province. 50 or 60 of them across the province to deliver demand response, in general. And we also have the Peak Saver program, so that's provincial in scope. And through AIRON and trying to identify buildings that can participate at basically multi-level. You've got the ability to get access to the building automation, control things remotely, using that system through the ANT system that he's got so he can message back to the building owners when required, and using the systems to identify when the grid's in distress. Using these types of communication tools are what is making a smart grid, and it's only going to get bigger, deeper, wider. Our kids, smart meters were put in not for us. Our smart meters were put in for our children so that they understand the price of electricity and what peak demand is. I was at the hockey game, sadly, a few weeks ago, and Toronto Hydro around the rim of the ACC has got power blitz, and all they're talking about is peak demand at a hockey game. And it was I found it staggering that they're actually bringing that up and educating the public that peak demand is the king of the castle. Because everything has got to be built, developed, and run for a peak demand system. And at midnight, what do they do with the excess? And we all hear the media talking about, negative energy costs. Well, the system is designed for a peak. The system isn't designed for midnight when we're not using it. So that is the smart grid in general, and it's going to get more complex as the next slide identifies. You've got plug-in hybrid cars. They're coming. We will get them. It's just going to take time and adoption. I'd like one. The one box that you see down at the bottom, the distributed generation and storage, that's another very big component. It may not fit with this group today, but integrating that strategy with your customers to have a clean power production source that can be activated when required, it's got significant revenue opportunities to it. So many buildings you're in now that you guys service, touch, work with, they have a backup generator. And that generator sits in the basement, sits on the roof, sits in a box out in the parking lot, and does nothing. It's there when needed, maybe once a year. They're forced by code to run it monthly for a half an hour, and it spits out a bunch of black smoke. Those engines, when cleaned up, when they're run as efficient as our cars, when you put on catalytic converters, when you put on a bunch of emission controls, there is no more black soot. You can now follow a Volkswagen diesel, but no soot, right? They're clean. They're in every driveway, or they want them in every driveway, but those engines can then be used for a demand response call. When the province is in distress, you literally flip the switch on that generator, and all of a sudden you're now getting a payment for that service. So you turn a liability or an insurance policy of a lump of steel in the basement or whatever into a revenue generating source. I work every day with those types of customers to try and help them understand that you've got an obligation to your stakeholders, to your tenants, that you can utilize technologies and systems to help benefit from that. And rolling in a demand response call, rolling in a building automation system as part of that play just widens and deepens the incentives that are available. So it can make quite a difference on the bottom line for a company. The bigger, the better. I can share that. Like I said, there will be a slide. I've got another slide coming up on the financial model. And this slide kind of clearly identifies where we're headed. Again, I think we've all seen it. You guys are in the front lines of trying to implement this from a corporate standpoint and in the customers that you're working with, but understanding that you are on the front lines and you guys help the companies make some of these decisions. Demand response isn't going to go away. The FIT has been reevaluated, the CDM is being reevaluated, everything is being reevaluated because we're running out of money. Demand response is the cheapest revenue source for the province to generate power because it doesn't cost anything. They're not having to build a new power plant. It's that in my backyard model disappears because it just disappears off the grid. So that's again one of the key components to all of this. Communications are going to be the key. You know, looking at some of the technology that's over here on the table, without that technology, it's not capable. Buildings are not smart enough to do some of this stuff. And you know, in speaking with some of my colleagues here, having maintenance plans, having, you know, touching the systems on a regular basis and maintaining the system so that they're operating optimally and can perform. Typically in a demand response world, you're working on a 3 to 4 year plan. So this plan has got to be implementable, repeatable for 3 years. So that means you have to touch those systems again, which in your case generates another service bill or another service ticket to make sure that everything is operating in its state the way it should. So that was, I guess, the message that I really wanted to try and convey, that demand response is a revenue generator. It's a positive solution to introduce to your client base to help them understand that with no cost or very little cost and a smarter control of a building, they can have a positive impact on their bottom line. And these are real checks, guys. They're not going against your hydro bill. It doesn't get paid or attached to your utility bill. It is a check that comes on a quarterly basis for participating in the program. So, and the checks are significant. I'll just leave it at that. So how does demand response work? What makes it work? What makes it tick? We get a signal from the ISO, Independent Electricity System Operator, and that signal is for the reasons I've shared with you, the cushion, the grid cushion, or the pricing, whatever the reason is, we get that signal. We are monitoring that grid stability on a minute-by-minute basis, and the pricing levels on a 15-minute interval. We've got direct access to the ISO, and they send a message to our Mississauga head office, and we are then put on standby notice. And they give us a 4-hour window to let our customer, our portfolio, be advised that today we may have to play. Be aware. So it could be game on at a certain time today, and it's a contractual time frame. They have to give us 4-hour notice, and then we are then under contract. We have to advise the customer base that it potentially could happen today. From there, we are then given a confirmation 1.5 hours before the time that you have to perform. And that is the signal point, and the messaging goes out to the market. So via email, via text message, there's a whole bunch of systems that are used to get that message out. So basically it's game on, and we use that as our, and I can tell you the office, it's a mad scramble. So of 365 days a year, we had, how many? It was 14 days last year that it happened. You could double your staff for those 14 days, but for the other 335 days, you sit around and wait for something to happen, or you're working on settlements. So anyways, the system gets activated, and you've got 1.5 hours to respond. In the morning, when you do get that 4-hour notice that today's a potential call, the customer has to be advised that yes, they can participate as planned, as the BAS has said it can perform. Yes, we can perform. Or that day, the BAS is not capable of performing. We are in maintenance mode. We've got some things disconnected because we're upgrading systems, so you can't perform that day. Okay, then somewhere in our portfolio, we have to go find that contracted amount from somebody else, because under obligation to the OPA, we have to deliver that set amount. As I shared with you, we have 300 megawatts, so that's a big number to find out in that marketplace. So anyways, it's got to be delivered. From there, once the activation notice and the time frame, and like I said, it's from 12 noon to 9 p.m. at night, you've got to do it, and it's only Monday to Friday, so you'll never get called outside those program hours. You'll never have to perform on the weekend when the staff is away. You'll never have to perform after 9 p.m. Because typically the grid stability has cooled, the issues have cooled off. So with the demand response, we have a access to your hydrometer as part of the agreement. We're directly connected to your hydrometer, and we can tell you that you're performing positively or negatively. The building automation system isn't performing the way you had contracted. I can't identify what systems are not in play on site. Again, that's the building automation's job and your guys' job. And I would think in the notification system, you would want to notify the building automation contractor so he's aware that it could be game on that day. You want to notify the building manager, it could be game on that day. And quite potentially the operations team or the facility guy, just so he makes sure that it's all hands on deck for that day. And there's a lot of things that can be activated, and I guess the next slide will identify that. You've got a built-in BES protocol. As I said at the beginning, I like to call it a DR day protocol, where it's embedded. The peak saver devices that we have in homes, like I said, we've got 220,000 homes in the province, and it's a dumb thermostat that when we send a pager signal to that thermostat, it activates the thermostat 2 degrees up in the winter or in the summer and 2 degrees down in the winter, and that's all it does. So from that 220,000, we probably get, I think it's 5 megawatts in peak demand for that period that's curtailed. So that's a fairly simplistic view of this whole thing. And it's simply a pager signal activating a device provincially, and it's one call made. And it's seamless to the homeowner. No homeowner is ever called back and complain. No homeowner is ever, I'm too cold, I'm too hot. Typically it's happening in the summertime. I guess 7 of the 11 events last year were in the summer, so people are not home. So their air conditioners are running all day. All of that kind of stuff, it's a non-issue, and it's for 4 hours. So it hasn't impacted that home or that household. So you translate that to a commercial building, and it's the same effect. If it's done effectively, activating all of the systems that I've listed here, and I'm sure you guys can think of more systems that you could impact. And quite honestly, I can't imagine how many fountains you guys actually control, how many elevators you actually control, but there's where connecting them to the building automation system, creating a DR day protocol, creates a little revenue for yourselves, because you have to add more things to it as part of your building operation solution, if you will. So I always try and put as many things on as, if you don't control it, you can't affect it, you can't reduce it, so you can't be paid for it, is the simple way I put it. So the key is trying to find and identify equipment on site that could be curtailed. And on a peak, screaming hot summer day, does anyone really care if the water fountains are running out front? Absolutely not, right? It's not going to impact operations per se. We do a lot of the shopping malls, Vaughan Mills, all that kind of stuff. No one's ever complained that the fountains have turned off for 4 hours on a screaming hot day. The escalators, 1 out of 3 escalators, stop running for 4 hours. They put a sign up that they're under maintenance. It's very simple, but those are proven energy reduction, and that's what they get paid for. So again, it's being a little creative. I hope I'm inspiring your minds to think about some of your customer base and some of the things that you could impact. And I'm trying to instill a concept of how can I increase revenue for my company and connect more loads that we currently don't control that could offer a revenue stream to the customer that didn't know was there before. And then I've gone through the load displacement. So the hydrometer is consuming this much at a certain point in the day, and every day it consumes this much, and you turn on that backup generator and all of a sudden that load goes down to here. That delta is what you get paid for. So the on-site generation concept is equally as lucrative. They don't discern from a kilowatt being curtailed or generated. It's the same payment and the incentive amount. And there comes the incentives page. So it's real money. You're somewhere from $80 to $100 per kilowatt curtailed. And I state that it's when it's curtailed. The reality is when you create the protocol, when you create the DR Day plan, you've tested your plan, and you enter into a contractual agreement, you are then enrolled in the program. You then get paid quarterly. Whether you actually have to activate, perform of the 11 times, you are paid every day. So every day that your demand is here, and it shows that potentially you could go to here without doing anything, you get paid for that day. And our team in Mississauga, that's what we analyze every single day for every single customer, that their availability is what is still there. It hasn't been eroded. They haven't shut down operations for 2 weeks and didn't tell anybody. Because if we do get a call and that contract is in play, that you're supposed to be able to cut your load in half. But, oh, we're on plant shutdown this week. No. I need to know about that because we pay you on a daily basis for your availability. You get settled on a quarterly basis. So this little chart kind of shows you the incentives that you're available. And these are monthly payments, so you can see that on a year, the money is pretty staggering. So if you're curtailing a megawatt, 1,000 kilowatts, times that 22,000 times 12. It's a big number. Do 2 megawatts, use a generator, 2.5 megawatt generator. You're talking $250,000 plus a year for doing it and for using it, for it being available, for not necessarily having to activate it. It's maybe been activated 11 times. 15 times is the most DR has been called in a year. So companies can then plan, budget, and monetize participating in the program with virtually no cost. And I say virtually because there may be some management or some enablement costs from a building automation standpoint, but the numbers are real, and it can be financially planned because it's a contract they've entered into for 3 to 4 years. As of today, the program is running till the end of 2014. All incentive programs are running until the end of 2014. The government hasn't extended. Demand response is part of the long-term energy plan for the province, which is going to 2031. So they're using demand response as a play right well into the future. Again, it's a simple power plant. Instead of turning one on, they turn one off. That's how they treat us. We're the turn-off group. So there's your financial model. Before I flip this page, does anyone have any questions on the financial model? Yes?
So, us as BAS people, do we offer certain times to you because we know the system and through our BAS we offer it, or do you come to the end user and tell them when you need to turn it off today or tomorrow?
Essentially, we advise you when you can turn it off, or when you have to, when the grid is in distress. The protocol that you embed in the BAS has got to be capable. At 4-hour notice, you've got to be advised, and at 1.5 hour notice, you need to confirm that you're going to play. And at the moment, so the province sends a signal to us that it's 2 o'clock to 6 o'clock that the event is going to be required. So your customer base has to be able to respond at 2 o'clock to 4 o'clock as per the contracted amount.
Now, what if we can identify times that us as BAS people, times when you can reduce the load, and we can tell you, can that power be stored somewhere for later and generate revenue for our customers?
So the question is, can you store the energy that you normally would have consumed but are not consuming it and putting it into a storage device?
Say through occupancy, right? If we know that this room's not going to be occupied, we lower the lighting, that's saving energy.
Correct. So in that case, that is simply an energy saving strategy, and that I can't pay you for, but the customer's bill is going to thank you very much for. So, let's agree on the contractual relationship and the performance relationship. There's 2 different things. You guys have got to perform. You're bringing value to your customer base. With the province, we're a certified aggregator for the province. I can't contractually pay you for that But I think your customers are looking for you to do that. And that's your value add. I would have to say that is your value add to the marketplace. And if you're not doing it, your competitor is. Does anyone else have any questions? Yes.
Is there a limitation on running backup power for load displacement? Do you have to change your C of A for
Correct.
do that?
Correct. It has to be clean emissions, and I started that portion of it. It's got to meet 2011 MOE, Ministry of Environment emission standards. And the C of A is a critical component. If anyone have seen this certificate of approval, a C of A, all these generators, when you build a building, are typically named in a C of A as emergency backup. When you apply to the MOE for a peak shaving C of A, you want to amend that C of A that I can use it for other requirements other than just backup. It must meet very stringent emission standards. No more stringent than your cars. It's capable, it's doable, it's repeatable. I can even put it as simple as that. You can go to every engine is somewhat the same. It's an internal combustion engine. Whether it's diesel, whether it's natural gas, so they can meet those standards. So that's a good question. And that is my arm wrestle every day, is that C of A amendment. The Ministry of Environment is at the City of Toronto today trying to get through some of the red tape that's required. So I'll keep moving. If there's no more questions, we'll keep
One
this.
more.
Oh, sorry.
One
Yeah,
more.
sure.
I'm wondering if there's any financial penalty, aside from not actually going through with the curtailment incentive for a customer not abiding by the contract.
This gentleman has asked a very good question. So the question was, are there financial penalties if I do not perform, right, to the contract? The answer to the customer is no. The aggregator has to absorb those penalties. Our portfolio, and that's why the province has set up an arm's length system in the province. So they've got the provincial government, right? So that's the one body. Then they have an aggregator is the intermediary between the customer. And our portfolio has got to deliver as promised. If a customer does not perform 3 times, we kick them to hell out of our portfolio is what it means, because we've absorbed 3 penalties on their behalf. So the key message is doing it right the first time, doing it right when you enroll, doing it right when you put the DR-Day protocol embedded in that BAS system. We've tested it, and I'll show another slide where we're going to test it twice, in actual fact, to make sure that it can perform as promised, and the building owner, the building occupants have not complained, there's been no issues. So that's our first test. Then the second test, we'll do it at a different time frame to ensure that it's met its performance criteria, and we might even reduce the curtailment amount or the kilowatt amount just to err on the side of caution. So there are no financial penalties, and that is again the burden we absorb and if they don't perform, then we've got to go back somewhere, call up one of the steel mills, guys, can you slow that line down that you're working on this afternoon? We've got to find it somewhere, or we just pay the penalty. So a good example, and I'm working on this project, is a water curtailment. Water facilities, essential service in the province, they all have significant backup generators, very big backup generators. So I've got a contract in front of them, and they've got to be able to perform as per contract 3 days in a row. And the water group, I can't do this 3 days in a row, not a chance. I can pump water into all the reservoirs. You tell me a day before, and I've got a special condition that we're set out. We'll pump water the day before. We'll fill all the reservoirs all night long, so that if we do confirm a call tomorrow, we'll just use the reservoir water. But I can only do that 1 day, maybe 2 if you give me again enough notice, but I can't do it 3 days in a row. It's game over. So as a company, we had to make a decision. Do we absorb, because water is unique, right? If the water main breaks, we've got to. So anyways, we've given a concession, and they don't have to perform as per, and we're going to absorb their penalties. So there's a special circumstance for everything that you've got to do. And if a pure power outage happens in the province, we're under curtailment. Let's say it's 2 o'clock on August the 7th, and that, you know, we know the grid's going to be in distress. They're importing power because it's screaming hot, and it's game on. Everyone's performing. BAS is activated. Everything's doing what it's supposed to do, and all the lights go out. Well, the reality is you have to turn on your generators, run the building as you have to run it, and there are no penalties for that. So, any other questions? Very good questions, by the way. Very good. Any other thoughts? I'll keep on moving here. So, how does it start? It's very simple, and again, you guys are the front line. Like, I don't need to do a lot if we work together. The on-site assessment, you guys are there. You're touching it. You're seeing it. You understand the buildings. You're managing it. And if you're not touching the various devices and things in the site, it allows you to go in and identify the loads that are not connected to the BAS and put a plan in place to put them on the BAS, implement that change. So once you have done the assessment, you've viewed all the equipment that's on, it's sheddable, potential sheddable load. You know, you change the hertz on, you know, on the stuff. You work with the elevators that you could impact them when required. Put the sign out front. You know, you go through the entire system, if you will. Second step is we then do a test. We do a dry run just next Thursday, 2 o'clock. Activate as planned. So that's our test, and I do these on a weekly basis for the customers that we work with. We'll do a second test on a different window, so we work fine from 2 till 6. How about we do 6 till, or 5 till 9, just to make sure that everything operates in plan for that. And it could be 2 different curtailment amounts, right? The building may be different 5 to 9 than it is 12 to 4 or whatever. So we will not contractually obligate the customer to more than the minimum amount that you can produce or curtail. A generator is easy, right? You turn on a generator, it's going to deliver 300 kilowatts. Doesn't really matter what time of day it is. But if your building only consumes 300 kilowatts up until 6 o'clock and it drops to 150 after 6 o'clock, I can't pay you for 300. I can only pay you for 150, because that's the most. If you get called 6 or 5 to 9, that's all I can pay you. So, DR agreement, next, because we've proven it, we've confirmed it, we enter into a contract with the end user, the customer. The OPA does their hoops and dances and side steps and everything else that they have to do to accept it, and it gets government approval. And you basically then are accepted into the program. We come back and do a welcome to the program. We have literature that can be posted on elevators, on motors, on devices, on the BAS system. Like, we've kind of created I worked with, on other systems where we create a DR day protocol, and it's just on the home screen of the BAS system. And when that button gets pushed over there in the bottom right corner, it activates as planned. So that is, that's what we determine as commercial operation. So the next slide is a good one. I'm sure there should be lots of hands out for this one. Unique challenges, and there are many, and they are vast, and they are varying, and I can't tell you what they're all going to be. You guys have to tell me what the challenges are. I have my own set of challenges, so I'll leave it at that. But the biggest challenge remains is the BAS system, and you guys in the field not actually capturing the opportunity and embracing the opportunity that is presented to you. You're forced by the building manager to cut, keep it simple. I don't want to see any invoices. Well, hold on. I'm not here to send you an invoice for something that you don't need. I'm here to do something that's new and innovative and should be part of a wider plan that you're looking at. So that, again, is a big part of trying to embrace the concept. We get this all the time, a year into the plan where the BAS system gets overridden. They've made changes and someone's forgot to, that little icon down on the bottom of the screen, that's a DR day protocol. They forgot to connect that new system or that new equipment to that protocol, and all of a sudden they can't contractually deliver what they were supposed to deliver because no one's tested it, they haven't maintained it for whatever reason. again, I put on the BS, not economical or it's long payback. You know, we've asked to get it upgraded. We've asked to connect more loads. If there's small loads in a site, the payback may not be worthy. So those are some of the questions you've got to really ask. And you know, some of our discussions this morning, as well as the equipment failures or dirty filters and all that kind of stuff, can really impact the performance of a BAS protocol or a DRD protocol being viewed as a successful event. You know, so they can be measured. A measurable reduction can take place. So like I say, the challenges are wide and varied. They really depend on your guys' ability to keep the eye on the building and stay focused on the customer site. It allows you to be there more regularly. I simply turn it right back to you guys. It is a business opportunity that can benefit your firm, keep your guys busy as well. If there's a revenue stream, and remember, I've been paying quarterly for this plan to be happening. So they're receiving checks regardless of not being called. All winter, no calls. We had one call in November, but so far there's been no calls this year, and everyone's been receiving their quarterly payments as being available. So the money's there. So in conclusion, as Rodan, as the leading smart grid energy supplier, it is I use the term a killer app. We are like a power generator. Instead of being turned on, we get to turn off. So that's a very big thing for the province, and it's only when required. There's not many things. A nuclear plant you can't just turn down, right? They run. You can't shut down at Niagara Falls because, in this case, they can shut us down within an hour and a half's notice. You're turned, you're activated. That's the bottom line. Conclusions, you get to help your customers upgrade their BAS. You get to modernize the system to be able to participate. You're now an integrated partner into their system. Not that you're not there already, but you're bringing new and innovative solutions to the table. The idea is it allows you to send another invoice. That's, I guess, my view, is it allows you to do that. I put earned revenue at no risk because there are no financial penalties. Customers get to earn revenue, which in turn should be generating revenue for yourselves. The energy reductions do show up on a hydro bill, and those are straight pass-throughs to the customer, right? I don't touch them, you don't touch them. Customer gets them, and they're real, because they're not getting paid unless it's been measured and verified. And I guess the last point would be to use a trusted demand response partner. We are doing Peak Saver. We're the largest in the province. We are the only Canadian company doing it. And I guess that's the key message is, on that same note, we've heard a lot of the distribution or the LDCs. The Patriot Act is now starting to come into play, where the demand response aggregators are all based out of New Jersey and Chicago and that kind of stuff. So they're not allowed to send the data down the states. They can't settle them because it's leaving the country. So anyways, use local, be local, shop local. Thanks everyone for your time. Now, I guess, is there any questions? Are there any questions before I move on and we'll keep things moving, or I'll turn it back over to Rick here and let him do his job.
Yep, go ahead.
So say you give a customer a call, like say Brock University right there, have a cogen, and other places as well. If they turn that cogen on and generate the power, they get paid.
Yep. If they don't turn it on, but they've enrolled in a program and that generator meets program requirements, they get paid regardless. They get paid regardless. Brock is a candidate I think we are working on. McMaster's a candidate we're working on. There's so many sites in that arena that are real, live, capable participants. They just don't know about the program. I can't get to every one of them. Same as you guys can't get to every one of mine, I can't get to every one of yours. That's why I'm doing these types of events, to get the awareness broader, deeper, wider. Any other thoughts out there? We're all good? Thanks very much, folks.
Thanks, Ted. It's very informative. I think that Ted's presentation kind of spoke to everybody in this room based on you know, what their role is in their organization that work for. We've got a contingency of consultants. We've got a contingency from ESCOs. We've got obviously our own contingency of building automation engineers and technicians that got a message from Ted. We've also got a contingency of energy initiative persons from DeFasco, City of Hamilton, Region of Niagara, I think McMaster, Halton School Board. And there's others that you know, I haven't even mentioned. That we've got a couple of representatives from some large condo developers that can see how they can apply what are really very basic automation initiatives. Everybody in this room works for an organization that has some form of building automation system inside their facility. Most of what Ted was talking about can be done with the system that you have. And it doesn't have to be an AIRON installed system. Mind you, we would love it if it was. But even any automation system can be reprogrammed relatively simply to load shed. It's not a complex programming initiative. So I really think that given the opportunity for the organizations that you represent, you should take some time and contact Ted and just ask him some questions. He'll probably be able to walk you through very quickly some form of you know, a spreadsheet analysis or just an open discussion, and be able to tell you what the potential for DR is in your facility. It may not be, and it probably isn't for everybody, but certainly amongst the guests in this room, I think that it's a reality that you should all probably take a step further after today and look at. From AIRON's perspective, where we see our involvement in this is, again, my initial statement goes back to systems being underutilized, and when they're being underutilized, they're usually being under-maintained. The whole point of this is, you know, if you're going to use the automation system through some form of a contractual obligation, then the system has to be maintained to work. If you don't go into an obligation or contract, the system still needs to work. Okay? And what we see is that everybody kind of thinks, oh, well, that's all automated. It runs out there in the background. It doesn't squeak when it breaks down. You know, it's all okay. Well, the point of it is it may not be okay. Sensors need to be calibrated. Systems need to be checked. Overrides need to be looked into. You need to look into the head end of the system and see who's been using that system and what they've been doing with the system. Because even without a DR program, I can guarantee you for those 40% or 60% of systems that we don't have under service contract, if one of our technicians went in that facility, they would probably within 10 minutes identify 10 to 15% energy waste just by the operation or lack of maintenance of that system, because the sensors aren't calibrated, fans are running during unoccupied periods, CO sensors that should be turning fans off are out of calibration, extending the operation of the fans, or worse yet, not bringing the fans on when there's a you know, high level of CO in a space. So from our perspective, what we're presenting to you guys is some initiatives to put the system to work for you, which will also help you pay for the maintenance of a system, which in turn, outside of the DR program, will also provide you ongoing energy savings and lower the cost of operating your facilities.